Hi guys, my name is Eli, and I'm back again. Yeah, this time I'm doing trick part 3 this time. I remember I promised you guys I would do a part 3, so I'll just take it from a question paper, then we're gonna work through this all together now. So I just finished writing my exams on Friday, so I just decided that now I'm gonna post the paper 3, the part 3 part of trick. So yeah, let's get down to it, and I hope your guys' exams went well, and I hope you guys actually managed to reach your goals and what you wanted for this term, right? So let's look at 4.1. So 4.1 says prove that. So basically, they're telling you to prove that the left hand side. They're asking you to prove that the left hand side is equal to the right hand side, right? And for you to prove that, we have to break this down in such a way that we actually get to the right hand side. We actually make a tan theta, right? So here we're gonna apply like our identity. So let me just remind you of the rules. So we have the first identity, right? So it's cos theta plus plus sine squared theta is equals to 1, right? So every time you see cos theta plus sine squared theta, it's always the same as saying 1. And then we can also make up more with this. We can also say that if we wanted to represent sine squared theta is also the same as saying 1 minus cos squared theta. We transpose this, we take this to the other side, then it becomes negative, it changes signs, right? And then we can also do the same for cos theta. We're going to say cos theta is equals to 1 minus sine squared theta. And also the one with tan. I think everyone is familiar with tan theta. Tan theta can also be written as sine theta, sine theta over cos theta, right? Yes. So we're going to apply this rules. This set of rules will help us reach to the right hand side in this scenario. Né? Okay. So let me just switch the pages for now so that I write in a more clear page. Yeah. Okay. So yeah. So here I've written the left hand side here. I've written the left hand side. So you always get a mark for writing your left hand side, guys. Remember that. Like every time you write your left hand side, you always get a mark for it, for writing the left hand side. So now here, what are we gonna do now? We can see we have 1 minus sine squared theta, so it has to change, right? So we're gonna change it to cos squared theta, né? Okay, let's change that. So I'm gonna say that this is equals to now what? I'm gonna say sine squared theta minus this is negative, né? Not minus, negative cos theta. Sorry about that. It's negative cos theta times sine theta, right? Over, so we're gonna say this is over cos theta minus, so we're gonna change this to cos squared theta, right? So this becomes cos squared theta. Okay, and then we're gonna also do the same here. We're gonna do the same here now. What's this now? So we're going to say oh no, so this is going to be equals to, basically we're gonna have sine theta, right, times negative cos theta times negative cos theta times sine theta, right, over cos. So I'm just gonna like fix everything, multiply out my negative, so this becomes negative cos squared theta. Okay, and I'm gonna say it equals to. So from here, okay, now this is where people often make mistakes, nah? So they'll say that, okay, I see that we have a negative cos theta, and they are multiplying, and I'm just going to basically just cancel them out. No, you can't just cancel them out where you see them. Remember that this is a negative cos theta, and remember you can see there's a dot here, nah? And also here there's a negative, there's a sign, and this is a minus sign. So that minus sign restricts us from actually cancelling them out. So it's a hint to tell you that no, you should take out a common factor. And in this case, we know that we wanna make tan theta. So, but we know that tan theta can only be written as sine theta over cos theta. So we can take out. Let's take out in what's the sine theta, as our common factor here, ne? So I'm gonna take out what now? Sine theta. Then what am I gonna be left with in my bracket? I'm left with so there's a negative here, so there's a negative cos theta, right? So I know that sine theta will multiply with itself, right? Which is going to be a negative 1, right? Why am I saying negative 1? Positive 1, I mean, ish. This is going to be a positive 1. A positive 1, right? So sine theta will multiply with itself. It will be sine theta, ne? And then we're going to say this is going to change to a minus cos theta, right? Yeah, minus cos theta, yeah, because then when we multiply them out, we're still gonna get a positive sine theta, and when we multiply this out here, we're still going to get a negative sine theta and cos theta, and they're multiplying, so it makes sense. And then from here we're going to say over, so let's take out cos theta here, okay, and then cos theta will multiply with itself, which is going to be 1, and then we know that cos squared theta minus cos theta, so basically the exponents are going to subtract, so you're gonna have cos theta minus 1, eh? Which is just going to be cos 2, cos theta in this case. And then from here we can see that now we can take out, because then we can see that the bracket represents multiplication, right? So that means that these ones will divide into each other, and hence we'll be left with and then from here we would actually be left with sine theta over cos theta, and this is actually the same as saying tan theta. So this is the same as saying tan theta, and therefore we have proven that the left hand side will be equal to the right hand side. Okay, that's good.